this lesson, we're going to learn about quadratic functions and specifically how to find the equation of the axis of symmetry, how to find the coordinates of the vertex, and how to use the axis of symmetry and the vertex to graph the function. Now I'd like you to take a look at these three graphs. You notice that the coefficient of x squared is the same in each one. That's 2, so it's y equals 2x squared. But the coefficient b, the coefficient of x, changes. And you'll notice that in the first graph, the axis of symmetry appears to be at, and actually is, at x equals negative 1/2 when the coefficient of x equals 2. When the coefficient of x equals 4 in the middle graph, the axis of symmetry moves to the left a bit and is now at negative 1. And in the third graph, when the coefficient of x is 6, the axis of symmetry again moves to the left. So from this we can see that that coefficient of x has an effect on the location of the axis of symmetry. Now the equation of the axis of symmetry for the quadratic function y equals ax squared plus bx plus c is x equals the opposite of b over 2a. Notice that the axis of symmetry is an equation because the axis of symmetry is a line. It's a vertical line, and its equation is x equals opposite of b over 2a. In the first graph, if we were to calculate the opposite of b over 2a, that would be, you'll see at the bottom, x equals the opposite of b is 2, so that is 2, over 2 times 2. And that, of course, equals negative 1/2. In the second graph that we saw, y equals 2x squared plus 4x, a is 2 and b is 4. So the axis of symmetry would be the opposite of 4, which is b, over 2 times 2, which is equal to negative 1. And in the third graph, where a is 2 and b is 6, the axis of symmetry is the opposite of 6 over 2 times 2, which is negative 3/2. So here are the steps for finding the equation of the axis of symmetry. First, determine the values of a and b in the quadratic function. Compute the opposite of b over 2a, and then write your answer as an equation, x equals the opposite of b over 2a. I'd like you to look at this function, stop the video, and find the equation of the axis of symmetry for this quadratic function. Do that and start the video when you have finished. Okay, so in this example, a is equal to 3 and b is equal to 9. The opposite of b over 2a is the opposite of 9 over 2 times 3. That's negative 9/6 or negative 3/2. And when asked for the axis of symmetry, in this case you should write x equals negative 3/2. Now try this one. Stop the video and restart when you have an answer. Okay, in this case, a equals 6, and the coefficient of x, b, equals 0. You can tell that because the x term is not even there, and that happens when the coefficient of x is 0. If you compute opposite of b over 2a, that's the opposite of 0 over 2 times 6, which equals 0. And then we say that the axis of symmetry is x equals 0, and that line is, of course, the y-axis. Next, I'd like you to, on your own, find the equation of the axis of symmetry for this function, stop the video, and restart when you're finished. Okay, in this case, a equals 6, b equals negative 36. The computation is the opposite of negative 36 over 2 times 6, which is equal to 36 over 12, which is 3. And the equation of the axis of symmetry is x equals 3. Now, next, we'll learn how to find the coordinates of the vertex. You may have remembered that in the graphs of the parabolas that we've looked at so far, the x-coordinate of the vertex is the same as the axis of symmetry. So if we take the function y equals 2x squared plus 2x, we remember that the axis of symmetry was x equals negative 1/2. And to find the y-coordinate of the vertex, we substitute negative 1/2 for x into the function. And we evaluate. You'll see that y equals 2 times negative 1/2 squared plus 2 times negative 1/2, and that equals negative 1/4. So the coordinates of the vertex are negative 1/2, comma, negative 1/4. For the function y equals 2x squared plus 4x, we learned that the axis of symmetry was x equals negative 1. And we evaluate the function for x equals negative 1, and we find y equals 2 times negative 1 squared plus 4 times negative 1. That all equals negative 2. So the coordinates of the vertex are negative 1, negative 2. And finally, for y equals 2x squared plus 6x, we learned that the axis of symmetry was at x equals negative 3/2. We evaluate the function at x equals negative 3/2. We get y equals 2 times negative 3/2 squared plus 6 times negative 3/2. That all equals negative 9/2. So the coordinates of the vertex are negative 3/2, negative 9/2. Now, I'd like you to try a few. Here are the steps to use to find the coordinates of the vertex. And I'd like you to find the coordinates of the vertex for this function. Remember, this is one that we've already done, so you should also already have the axis of symmetry. Pause the video, do the computations, and then we'll take a look at the solution. Okay. The axis of symmetry was at x equals negative 3/2, or we can use decimals, might make the computation easier for you, negative 1.5. We substitute into the equation. We find that y equals negative 13/75. So the vertex is negative 1.5, negative 13 3/4. And you can write that as fractions or decimals. I'd like you to find the coordinates of the vertex for this function. Again, we've already found the coordinates of the axis of symmetry, so you can use that in this step. Stop the video, do the work, and restart the video when you're done. Okay, so the axis of symmetry was x equals 0. We substitute 0 for x and evaluate the function. And we find that y equals negative 7. So the coordinates of the vertex are 0, negative 7. And finally, I'd like you to do the same thing for 6x squared minus 36x plus 1. Again, we've already found the axis of symmetry, so you can use that in this computation. Stop the video, do the work, and restart when you're finished. Okay, and here's a quick look at the result. Always notice that the vertex is a pair of coordinates and should be written just as you've seen it, with parentheses around it and the 2 coordinates there. Now, graphing a quadratic function is very similar to what we've already seen. We're going to use this example, graphing y equals x squared minus 4x plus 5. The axis of symmetry is x equals 2. The vertex is 2, 1. And you can work that out for yourselves. And we're going to make a table using x values to the left and to the right of x equals 2. If we know that the vertex is x equals 2, then we can just go 3 to the left, which would be x equals 1, 0, and negative 1. And those should be the same values as x equals 3, 4, and 5, those three values to the right. So let's look at the table. So in the center of the table, we notice that if x equals 2, y equals 1, and then go up 1 and down 1 from that, and you know that the y value is 2. Go up 2 and down 2 from that, you know that the y value is 5, and so on. After you have the table, you can plot the points. And I sometimes start with the vertex point, and then plot the 2 points on either side of that for x equals 1 and x equals 3. Then for x equals 0 and x equals 4. And then x equals negative 1 and x equals 5, and draw in the graph. I'd like you now, please, to graph y equals opposite of x squared plus 2x minus 3. Here are the steps. And here's the table. And this is what the graph looks like. Notice that the axis of symmetry is at x equals 1 and that this parabola opens down. Another one I'd like you to try, y equals x squared minus 6x plus 1. Here are the steps. And please stop the video, make the table and the graph, and restart the video to check out the answer. Okay, here's the table. And we'll notice that we have x equals 3 as the axis of symmetry right in the center of the table. We make the coordinate plane, plot the vertex, plot the points for x equals 2 and x equals 4, x equals 1 and x equals 5, and x equals 0 and x equals 6, and then plot the parabola. And this concludes our lesson.